let's talk about rates and orders of reactions. So as you all know, class, there are multiple rates and orders of reactions here. We have the pseudo first order, zero order, second order, okay, and so on and so forth. Right? Now, for simplicity's sake, we'll only be discussing class 2 orders of reaction, which has a greater significance in biopharmaceutics and pharmacokinetics, specifically pharmacokinetics. So we have the first order and then the zero order reaction. Okay? Now, a few definition of terms muna. When we say class rate, okay, it refers to the velocity at which a reaction occurs, how fast or how slow. And when we say order class, order of reaction, it talks about how the concentration of a drug or a reactant affects the rate of reaction. Okay? So ulitin ko. Order of reaction class talks about how the concentration, how the amount of drug can affect the rate of reaction. Kasi oftentimes, class, the higher the amount of drug entering the bloodstream, the faster would be the rate of reaction. In our case, ang rate of reaction natin dito would be the rate of elimination. Okay? Pero that's not always the case. Sometimes, no matter how high you give a certain dose of a drug, okay, ang tendency is, hindi nagbabago yung rate of reaction niya. Hindi siya bumibilis, hindi siya bumabagal. It stays at a constant rate. Okay, so yun yung pag-uusapan natin dito. So we have two types of order of reaction class. You have the first order and the zero order reaction. Okay, so first things first, what's the difference? Right? Zero order rate process class. This one follows the saturation kinetics. Okay? While for the first order process, we call this the linear process. Okay? Bakit linear? Ang assumption kasi class, pag isang gamot ay sumusunod ng first order process, so linear, the higher the concentration, the initial concentration, sorry, singit ko na lang ha, the higher the initial drug concentration, ano ang nangyayari sa rate of reaction? There is an increase in rate of reaction. Kaya sabi natin, ang order of reaction refers to how the concentration of a drug affects the rate of reaction. Or in this case, class, ang reaction na hinahanap natin is elimination. Okay? So are we clear? So class, a first order process is a linear process wherein if there's an increase if initially mataas ang blood concentration mo, ang tendency is mabilis din yung rate of elimination. That's the reason why class, drugs given intravenously. Okay, if you give a drug intravenously, ano ang initial concentration mo? High or low? Sabi natin, it's gonna be high because 100% marireceive agad ng patient mo. So dahil mabilis or mataas ang initial concentration mo, ang sa tingin mo ang gagawin ng katawan mo in response to that. Okay, since it's going to be, especially if a drug is following first order process, okay, bibilisan din class ng katawan natin ang pag-eliminate doon. Are we clear? Therefore, preventing accumulation of the drug. Are we clear? Okay. So class, if this is a graph, okay, this is the graph. So here's the concentration. Okay, this time ilagay natin yung concentration dito sa x-axis. Tapos yung rate of elimination, rate of elimination yan. Rate of elimination sa y-axis. So as I increase concentration, ano nangyayari sa rate of elimination ko? Bumibilis din. Okay, bumibilis din. Maliwanag? Okay. So as I increase plasma concentration, the rate of elimination also increase proportionally. Now that's a first order process. Okay? That's the first order process. Now class, please take note of this. 90% or more than 90% of the drugs in the market right now, class, starts at the first order process. Starts at the first order process. Okay? Meaning ang reaction niya, ang order of reaction niya will always be first order process. So majority of our drugs in the market will always follow first order process. However, okay, ayan na naman yung however na yan. Okay? There comes a time, class, wherein as you increase the concentration of the drug, nagkakaroon tayo ng tinatawag na saturation. Now, whatever that saturation point is, so halimbawa, Taas ka ng taas ng concentration. Taas, 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 taas. Hanggang na-reach mo yung point na to, which we will call the saturation point. Okay? Here's the saturation point. So what happens now, class, once you reach the saturation point? Okay? Ibig sabihin, napuno na yung biological system sa katawan natin. Ibig sabihin, na-reach mo na yung dose kung saan wala nang, napuno niya na yung lahat ng system sa katawan natin. Right? So if that happens now, class, palitan natin yung color. What happens now? Once the saturation point is reached, no matter how high I increase the dose, okay, or the concentration of drug in the plasma, ano nangyari sa rate of elimination ko? It stays the same. Once the saturation point is reached, class, this is the time where zero order kinetics occurs. Okay? So sabi natin kaya, di ba? All drugs will start as, will follow first order process. All drugs. Okay? All drugs, hanggat hindi pa nasa-saturate yung system mo. Okay? However, class, once you reach the saturation point, this saturation point here, yung total amount, total concentration, okay? The total amount of drug that will cause saturation. Okay? Pag na-reach mo yung saturation point na to, ano nangyari sa rate of reaction ko? It stays the same. So, pag nangyari na yun, class, that means your drug is already starting a zero-order process. That wherein no matter how high I increase the concentration, the rate of elimination has reached a saturation point. Meaning, the rate of elimination remains constant irregardless of the concentration there is, whether high or low. All right? So, are we clear? No matter how high I increase the concentration, the rate of reaction stays the same kasi na-reach mo na ang saturation point mo. Napuno ka na. Kumbaga, kahit ano pang gawin sa'yo, wala naman, hid ka na. Kumbaga. Okay? So, I hope that makes sense, class. I hope that makes sense. Okay? Now, you'll often hear this class being discussed sa pharmacy. Okay? Drugs like alcohol, ethanol, yung 0-watt power, warfarin, aspirin, theophylline, okay, then phenytoin, those drugs that follow zero-order reactions daw. Technically, class, all drugs, all drugs will follow first-order process. Yun nga lang, class, yung mga gamot na to, like phenytoin, alcohol, okay, they reach their saturation point early on. Mabilis nila ma-reach yung saturation point. Kaya sinasabi na lang natin na since ang therapeutic concentrations kasi nila is at the saturation point, so ang tendency is, sinasabi lang natin na, they follow zero-order process. Okay? Okay. Am I making sense? So I hope I'm making sense, class. Just ask question, class, when pag nalito kayo. Right? Pero ulitin ko lang. Okay? Most drugs kasi, class, in the market, for it to create a response, okay, para mag-create siya ng response, normally below the saturation point. Okay? So as long as you are giving the drug at a dose below the saturation point, then the drug will follow a first-order process. Okay? Will follow a first-order process. But once you give a drug, any drug, okay, naabot mo yung saturation point niya, the concentration at which nag-start na mag-saturate yung buong system ng katawan mo, system involved sa drug na yon, okay, the drug will no longer follow a linear process. Okay, will no longer follow a first-order process, but instead start to undergo a zero-order process, wherein na-reach mo na yung saturation point. So the rate of elimination remains the same. Okay? Now, sir, what about drugs like alcohol, phenytoin, warfarin, aspirin, theophylline? Okay, yung mga gamot na yon, those are drugs that are classified as drugs following zero-order process. Technically, class, at low doses, they follow first-order process pa rin. Yun nga lang, class, yung mga gamot na to, ang therapeutic concentration nila is very close to their saturation point. Are we clear? The therapeutic concentrations of these drugs, drugs classified as zero-order drugs, okay, are very close to their saturation point. So, ang tendency, sabi na lang natin is, since andun na rin naman sa saturation point, sabihin na lang natin na ito yung mga gamot that follows zero-order kinetics. Okay? Pero again, class, ulitin ko, lahat ng gamot nag-umpisa as first-order process. Nakakatalo na lang, kailan mo ma-reach ang saturation point. Okay? Luckily, majority of our drugs, malayo yung kanilang saturation point sa minimum effective concentrations nila. Okay, or therapeutic concentrations. Okay? So I hope that makes sense. Yeah. Okay, so why are rate constants important? Okay, rate constants, class, are the ones that we compute, okay, which determines how fast or how slow a drug is being absorbed, distributed, or eliminated. So there are three main rate constants, class, that we use here. We have the Ka, which refers to absorption rate constant. Okay, we have the Kd, distribution rate constant, how fast or how slow the drug is being distributed. And then, of course, because the most important, Ke, elimination rate constant, how fast is the drug being eliminated. Applicable lang, class, ang Ka for drugs given extravascularly. Kd, on the other hand, class, okay, ang topic natin dito is next meeting pa. Okay, pero class, we use Kd for drugs that follows two-compartment model. Okay, follows two-compartment model. Next natin pag-usapan yan. Alright? Ang Ke, or minsan K lang, okay, pero I prefer to use Ke as a term, class, okay, applies to all routes of administration. Meaning, lahat naman ng gamot, mawawala sa katawan. Okay? So, applies to both EV, IV, and EV. Kaya isa to sa pinaka-importanting kinetic parameter na dapat alam nating i-compute. Ituturo naman natin. Okay? Okay. Now, class, to determine the formulas being used both for first order and zero order processes, okay, let's first, before I talk about the straight line, class, let's first discuss how do we plot first order and zero order process. Okay? I think this is something naman na kasi na familiar sa inyo, pero sige, let's have a recap lang. Right? Now, class, if your paper, the paper that you're using is semi-log, okay? Semi-log. So, sabi natin, ito yung tsura niya. X-axis, andyan yung time. Y-axis, andyan yung concentration. So, para ma-indicate natin, class, na semi-log to, lagyan natin ng log concentration as an expression. Okay? Pag straight line yung ano ko, nabuo ko. Pag straight line yung nabuo ko, what is this? First order or zero order? Right? So, sabi natin, class, usually pag ganito, pag straight line, sabi natin, that's a first order process, right? The first order. This is pag na-plot sa semi-log. Now, kung sa cross-sectional graphing paper, yung ordinary graphing paper, cross-sectional, GP na lang, graphing paper. Okay? So, dito yung concentration, andito yung time. If you remember, class, pag nag-plot kayo dyan at straight line yung nabuo ko, straight line to, ha? Straight line. Sa isang cross-sectional, ordinary graphing paper. Sabi natin, class, pag straight line yan, ano ito? This follows zero order process. Correct? Okay, so yun yung naalala natin regarding sa plotting natin, right? So basta pag straight line sa cross-sectional graphing paper, ay zero order process yan. Pero pag straight line sa semi-log, ay first order process yan. Kasi pag nag-plot ako sa semi-log, tapos biglang nag-curve, okay, palit natin yung color. Okay. Kunwari, nag-plot ako dito, tapos biglang ang itsura ng graph ko pag ganito. Nag-curve siya. Pag nag-curve yan, sa semi-log, sabi natin, zero order process yan. At pag nag-curve naman sa cross-sectional graphing paper, umurbang ganun yung pag-plot mo. Mukha siyang curve. Sabi natin, ay first order process yan. Correct? Okay. Now, take note, class, again, ang order of reaction na tinitingnan, ang reaction na tinitingnan natin dito is the elimination reaction. Okay? How well is your drug being eliminated? So, basically, class, what are we creating here? Sa physical pharmacy ninyo, ginagawa natin on was, we're just plotting, right? We're plotting. We're creating lines. Correct? We're creating lines in your graphing paper. So, if we can still remember, class, okay, those lines, we can actually do some computations with that. So, if we still remember our geometry, Okay? We do have a formula for a straight line, which is y equals mx plus b. Ano ba yung y na yun? Yung sabi natin class, y refers to the data, any data in the y-axis. M refers to your slope. Okay, so how steep is your line going down? Okay, x would be referring to the data in your x-axis. Okay, and then b class would refer to the y-intercept. Y-intercept class is where your line connects with the y-axis. Okay, kung saan siya magkoconnect. So yan yung y-intercept. Now class, ulitin ko lang ha. Diba sa physical pharmacy, to determine whether or not a reaction, order of reaction is first order or zero order, we usually just plot it. Pag straight line sa semi-log, anong order of reaction yun? First order. Pag straight line naman sa cross-sectional graphing paper, anong reaction yon? Zero order reaction. Okay? So now class, dahil graphing paper, sa graphing paper, straight ang zero order reaction. Let's start with that. Iumpisa natin doon. Now class, pag nag-graph kayo using, when we're graphing plasma level time curves, okay, normally, sabi ko nga, ang nasa x-axis would be time. Ang y-axis would be drug plasma concentration. Okay? So therefore, class, if I want to convert these datas, I'm going to convert these datas. Itong y equals mx plus b. I want to convert this to follow the data that I have in my table. Okay? So ano yung y? Ano yung mga y na yan? So y class would refer to plasma concentration. Concentration. M, yung slope. Ano yung slope na to? Kung titignan nyo class, ano ang route of administration na to? This is intravascular. And the line class is going down. Right? So this is in the elimination phase. Now, notice class, ang pag-eliminate is constant. Constant yung elimination natin. So meaning, this is my elimination rate constant. So therefore, class, ang slope ko will be my elimination rate constant. Okay? Ano naman yung x-axis? Ano ba yung mga data na sa x-axis? It's time. And the y-intercept refers to, what's this? Sabi natin, it's where your line connects with the y-axis. So this is concentration at time 0. Are we clear? Okay, so let me rewrite this class in a way na mas maintindihan natin. So y equals mx plus b. Palitan natin ng kulay para mas sa papansin natin. Oops. So ano yung y? Sabi natin, this is the plasma concentration. So Cp. Ano ang m? Sabi natin, this is the rate of elimination. So Ke. Now class, please take note the slope can either go up or go down. Pag going up ang slope, pag ganyan yung slope, ano yung slope ko? It's a positive slope. Pero if the slope of my line is going down, yung direction niya pag ganito, it's going to be a negative slope. So it's important class, yung slope ko dito, lalagyan ko ng negative sign to indicate that the line is going down. Kasi kung hindi ko lalagyan ng negative sign to, ang lalabas sa line ko, it's going up. Okay, which is of course not the case. Kasi elimination to, pababa yung line natin. So therefore, it's important to put a negative sign here. Then x would refer to time. Okay, so that's multiply. So plus, what's b? B refers to C sub 0 or the concentration at 0 time. So just so you know class, this is already the formula for zero order process. Okay? If you allow me to rearrange this, ang lalabas yan, Cp equals CO, positive CO, plus minus times Ke, negative Ke T. Okay? So negative Ke T. So this will now be the formula for zero order reaction. So tingnan nga natin. So pretty much the same. Correct? Okay. So class, yan ang formula na ginagamit natin for zero order process. Okay? So similar to this one. So here it is. Alright? So, saan nanggaling yung formula na to? Nanggaling ang formula na to sa y equals mx plus b. The formula of a straight line. Okay? Now, take note, kasi straight line ang zero-order process sa isang graphing paper. Ang formula na to applicable sa isang straight line sa graphing paper. Are we clear? Again, class, very important dyan. The negative sign there indicates that the slope is decreasing. Okay, pababa siya. To indicate to indicate elimination rate constant. Or na-eliminate yung gamot. So, are we clear? Are we good? Any questions so far? Okay? So, yan ang formula for zero-order process. Now, sir, what about first-order process? Okay? So, anyway, yan ang zero-order reaction. Straight line in a cross-sectional graphing paper. Okay? So before I talk about first-order pala, pag-usapan muna ito. So, class, in zero-order process, the plasma level versus time curve during elimination phase is linear. Okay, oftentimes. So, it only occurs, class, when a system is saturated. So, sabi ko nga, class, lahat ng gamot will start as first-order process. Kailan lang siya nagiging zero-order? Pag na-reach ang saturation point. May mga tinatawag lang tayo na drugs that follow zero-order reaction simply because those drugs, yung kanilang saturation point is near to their therapeutic concentrations. Okay, to the minimum effective concentrations nila. Okay? Okay. So, for drugs class that follows, once a drug starts to undergo zero-order process, okay, the drug will be eliminated every hour independent of the concentration of the body. So, ibig sabihin, yung kanyang rate of elimination remains constant all throughout, irregardless of the concentration in the body. So, let's try this one, class. So, a suspension, 125 milligrams per ml, decays by zero-order kinetics with a reaction rate of 0.5 milligram per ml per hour. So, what is the concentration of the drug remaining after 3 days? So, class, the answer should be 89 milligrams here. So, how did we compute for this? So, ano ba yung given natin? First right are given. So, we have C0. Kasi yun yung starting concentration. It's 125 milligram per ml. What's the KE, or the elimination rate constant? It's 0.5 milligram per ml per hour. Now, class, ang time natin dito, what will be the concentration after 3 days? So, ang required sa ating i-compute dito would be CP. Was unknown. Right? So, hindi natin alam yung plasma concentration natin. So, therefore, class, how do we solve for this? We'll just simply use the formula of zero-order kinetics. So, sabihin natin, CP equals negative KE multiplied to T plus C sub 0. Okay? So, negative KE, that would be the negative sign multiplied to 0.5 milligram per ml per hour times, what's our T? 3 days. 3 days. Plus, what's our CO? 125 milligrams per ml. So, question! Cancelable ba to? Aking KE at saka yung time ko. So, obviously, class, no. It's not cancelable. Bakit? Ang rate of elimination ko is in hours per hour. Ang time ko is in days. So, obviously, I need to convert this into hours. So, sabi lang naman ang gagawin nandito would be, so, lagyan natin proportionality. So, there's 24 hours in 1 day. So, therefore, cancel, 24 times 376. 72, sorry. Ano 76? So, 72 hours. So, therefore, this is negative 0.5 milligram per ml per hour times 72 hours plus 125 milligram per liter. So, cancel. Okay. Saglit lang. 0.5 times 72. 36. Negative 36 plus 125. So, So that will give you 89 milligram per liter. Isa sa mga pinaka-importante class na dapat talagang ano dito is yung concept between first order and zero order. Okay? Yun yung importante sa akin dito. Okay, paano ko na-derive yung formula? Paano na-derive yung formula? Sabi natin, galing naman sa y equals mx plus b. Okay, then kasi class, pag ilalapat mo na yung ano dyan, yung mga data mo, mag-iingat ka lang lagi sa conversions, compatibility ng mga units. Okay, something class na I'm sure sawang-sawa na kayong gawin sa farm cal pa lang. Okay, and other subjects ninyo that required you to compute.